Hello, geometry students. Welcome back to another video lesson. Today with Mr. G, we are going to look at proofs, particularly proofs using our isosceles triangles and adding to some of the definitions and theorems that we already have. So first and foremost, I quickly generated a list of kind of what we went through in first semester, to be honest. You're going to want to make sure that you have all of these written down somewhere. This might be a good spot to pause the video and to just jot those down and make sure you understand what they mean or even what they look like. All right, hopefully you wrote those down. If you do need a document, or you need a resource of some sort to help you clearly understand what all of those are, please reach out and let me know, because we're going to use a lot of these in second semester. And we're going to add to that list right now. So here's an important note. It's the same theorem, if you will, but it's two different ways of looking at it. So here's the first part. It's called the isosceles triangle base angle theorem, or ITBA, or even you'll hear me call it ITBAT. ITBA or ITBAT, isosceles triangle base angle theorem. What this says, if two sides of a triangle are congruent, then we know the opposite sides are also congruent, right? And it only goes in this direction. If the sides are congruent, then the angles are congruent. ITBAT, sides to the angles. The second one is called the converse to ITBAT, or SITBA, or even SITBAT. That goes the other way. If I know that two of the base angles are congruent, then we can conclude the two sides are congruent. So make sure, if anything, I would write down the isosceles triangle base angle theorem, ITBAT, and then this picture, and then I would write down converse in the isosceles triangle base angle theorem, SITBAT, and then that picture, so that I understand what the two of them are showing us. Now, we've got two examples for proofs that I'm going to walk through with you. I'll walk through the first one, and then I'm going to have you answer some questions along the way on the second one. Example one, we've got this crazy-looking figure over here to the right. The figure at the right has AB congruent to AC, and angle 1 is congruent to angle 2. Look at that. AB congruent to AC, so they put the red marks for us, and angle 1 is congruent to angle 2. So we could put those red marks in those angles if we kind of wanted to. This angle 1 is congruent to angle 2. We are trying to prove that line BC is congruent to ED. BC is congruent to ED. And if you think back, we got to try and figure out what are some ways that show lines are parallel. Right? So I'm going to go back and look at this list. What are some sets of things that tells me lines are parallel? That's this set right here. Right? So I'm looking to try and get one of these things to somehow happen in that picture. That'll help me identify that the lines are parallel. All right, so what's step one? Always, it's the given. AB is congruent to AC, comma, angle 1 congruent to angle 2. How do we know that? That's always the given. Always given. Now, let's use this information up here at least. AB is congruent to AC, which they marked. And let's just focus on this triangle ABC up on top. If I know that the two sides are congruent, what do we know about the two angles? Well, we know that angle 2 has to be congruent to angle 3. What says that? Let's go back one page. I got the sides congruent. What tells me that the angles are congruent? That's ITBAT. The sides are congruent, tells us the angles are congruent. So we can just write ITBAT, isosceles triangle, base angle theorem. So now I know angle 1 is congruent to angle 3. 2 is to 1 and 2 is to 3. So what happens, right? Look at this. I've got 1 is congruent to 2 and 3 is congruent to 2. They're both congruent to the same exact thing. So what allows me to jump to this step and say that angle 1 is congruent to angle 3? Well, that is the transitive property. It allows us to tie 3 pieces of information together because they've got one thing in common. Transitive property. Okay, transitive. So now we know that angle 1 and angle 3 are congruent. So if we just look at, and I'm going to just try and draw a box around it up here, what could we call angle 1 and 3? Right? Here's a set, and here's a set. They're both in the bottom left. And if they're both in the bottom left and they're congruent, those are corresponding angles. And if corresponding angles are congruent, the lines are parallel. So the lines are parallel. BC, that line, is parallel to line ED. And how do I know that? Corresponding angles postulate. Corresponding angles postulate. And I'm just going to abbreviate since I'm writing with a mouse. All right, so we're kind of walking through. The first part there was to know that we had it, bat, and then we're using a lot from that previous list. Let's take a look at number 2. Given that point S and point T are on circle 0, right? They're telling me that S is on the circle and T is on that circle. We want to prove that S is congruent to T. So what should we do first? Well, S and T are on circle O. What's the reason here? What's the justification? Given. Always given for this first step. All right, remember, we're basically taking this and recopying it down for the first conclusion and writing the word given. Half a point, half a point. Save yourself some points if you need them. All right, now, number 2. We're trying to somehow prove that S is congruent to T. That S is congruent to T, that the two angles are congruent. So somehow, is there a way for me to show that these two sides are congruent? Well, what do we know about OS and OT? They indeed are congruent. OS is congruent to OT. The trick is to try and remember why. This would be because of the definition of a circle. Definition of a circle says any point on a circle is equal distance from the center. Any point on a circle is equidistant from the center, right? They're called radii or a radius. All right, so we just showed that those two are congruent. If those two are congruent, we can jump right away and say that angle S is congruent to angle T. And the reason being, if I've got sides congruent, what allows me to say the angles? Once again, this is it bat. The sides congruent mean the angles are congruent. It bat. So today you're going to have 3 of these to try on your own. Really try and work through them. Look back to that definition list that I had here, at the beginning of this video. Really make sure that you wrote down these notes here as well, and see if you can't work through the 3 problems before you check your answers. The more you practice, the more familiar you're going to become with those patterns. If you need that list or you have any questions, please make sure you reach out. Otherwise, have yourself a wonderful weekend, and until next time, everyone, stay safe.